Today we're going to do the Kruskal-Wallis test, Chapter 11, Section 3. It's on page 608, and it's the try it yourself, number 1. A couple of things before we get going. It's a fairly brutal test statistic to have to compute. And what I mean by that is the formula is pretty lengthy, and to be able to get through the formula, it takes a bit of time. So I've got some stuff on my fantastic, I'm being sarcastic, whiteboard. And then I also have some stuff on some scrap paper that I'm going to show you. So your test statistic is figured out by doing or getting H, and it's 12 divided by, and the big N, the capital N, is all of the sample sizes added up, and that's all of them summed. And then this is all of them summed plus 1. Next to it, you're going to have the rank sum of that category or column squared divided by the sample size of that category or column plus the rank sum squared of the second category divided by the sample size of the second category. And you keep doing that through all of the categories. And then lastly, you subtract, or over here, you subtract 3 times your, again, sum of your sample sizes, plus 1. We compare our test statistic to Table 6, a chi-squared distribution, and we use the degrees of freedom, k minus 1, where k is the number of categories that you're looking at. So real quick, K is your number of samples, number of categories. N sub I is the size of the ith sample, how many items there are in that sample. Big N is the sum of all of the samples, so N1 plus N2 plus N3 and so forth. And then you're going to have all of the data jumbled together, and you're going to rank them, and then you're going to take the sum of the ranks. And so R sub I is the rank sum of the ith category or column. And they can set them up in rows too, but I think your book often does them in columns. All right, so on the try it yourself number 1, just to show you the length and the detail you have to get into, and this is not particularly great, but so what I have here is from the third sample, the number is 57.6, and it has rank 1 because it's the lowest number. From the first sample, I have 63.3, and it's from it has rank 2 because it's the second highest, or second lowest, forgive me. Then from sample 1, I have 74.8, and its rank is 3. From sample 2, I have 80.4, and its rank is 4. And you do that for all of the data. If you have ties, you have to do that thing that we've done in the past, where if it would be 4.5 and let me start over. So if you have two values that are the same, and they would take the rank 4 and rank 5, add 4 and 5, get the 9, divide by 2, and they will both get assigned to 4.5. If you have 3 numbers that are the same, take those 3 ranks, add them together, divide by 3, and they will all get that rank. Okay? So, what happened is N1 had 10 items, N2 had 9 items, and 3 had 9 items. So my big N was 28. The way you get your rank sum. So this is the rank sum of the first category. If I go back to my data, the first point that was in category 1 had a rank of 2. The next one had a rank of 3. So I just take all of the ranks, and you'll notice I have rank 1 is 2 plus 3, then plus 7 plus 8. So the next number in rank 1 or in column 1 had rank of 7, then rank of 8, then rank of 9. And that's how we got the 2 plus the 3 plus the 7 plus the 8 plus the 9 and so forth. In computing our test statistic, down here we had H getting computed. We had the 12 from the formula, and then we had 28 total items in our samples. Multiply that by 29 as well, and that's in the denominator. And that comes from the formula. If you travel back up here, it's n times n plus 1. Then the sum of the ranks for the first category was 121, and we square that, divide it by 10, plus the sum of the ranks for the second category, which was 128, and we square that, divided by 9, because there's 9 items in that sample. And then 157 squared divided by 9. And then we have our minus 3 times 28 plus 1 going on. That test statistic ended up being 2.01. I had a typo for a moment there, I apologize. 2.01. So based on that information, and we're comparing it to the test statistic, the critical value 5.991 that we get off the chi-square table. So because it's closer to the 0, it's in this region here, it's in the fail to reject. So part 1, fail to reject the null at alpha is equal to 0.05. And now, since we're failing to reject the null, we travel back up top. We look at our null, we look at our alternative. We're failing to reject our null. Our null is what we're keeping. We're tossing out the alternative. So the word claim gets a line through it. That means that we use insufficient. Insufficient evidence to support the claim. All right, hopefully that helps. Thanks for your time, guys.